Hello, my name is Chris Fitzpatrick, and welcome to my Lab 3 presentation. So, the purpose of this lab was to calculate the net force of a black hole on a star and to estimate the mass of said black hole. The fundamental physical principles that were used in this lab were Newton's second law and Newton's law of gravitation. And a summary of the lab is that I calculated the net force, both parallel and perpendicular components, as well as the entire net force in GlowScript, and I also calculated the mass of the black hole. The star's mass was set to 2 times 10 to the 30th power kilograms, and the program was tested. The key formulas that I used in my calculations were P is equal to mv, or momentum is equal to mass times velocity, F net is equal to dp over dt, or the net force is equal to the change in momentum over the change in time, and F net is equal to gmm over r squared, or the net force is equal to the universal gravitational constant times the mass of one object times the mass of another object, all divided by the distance squared. Calculating the mass of the black hole, I used the formula mass of black hole, mbh, is equal to the magnitude of the net force multiplied by the magnitude of the position of the star squared, all divided by the gravitational force multiplied by the mass of the star. And the net force that I calculated was 8.10118 times 10 to the 28th power. The parallel component of the net force I calculated was 1.3025 times 10 to the 28th power, and the perpendicular component of the net force was 8.0015 times 10 to the 28th power. And the rate of change of momentum is equal to the net force, and combining the parallel and perpendicular components of the net force proves this. Alright, so here is my code. After setting up the mass and my Georgia Tech email as the seed, as well as editing certain parts of the code, the experiment was ready. And what I edited was based on the law of conservation of momentum, Newton's second law, and the fundamentals of gravity. So here's the first bit of code. I didn't edit anything here besides the seed. Then lines 51 through 150. And then lines 151 through 220. And for the what if question, if the black hole was instantaneously replaced with another black hole in the same location, and the star orbiting said black hole followed the same path, the mass of the black hole would also be the same. Because of this, we would be able to calculate that the mass is the exact same as the previous black hole. There are no forces acting upon the star besides the gravity of the black hole, and the gravitational force of a black hole is dependent on the weight of said black hole, so the mass has to be the same as the previous black hole. Now to show you my GlowScript. Here it is. As you can see, I've got my code here. And running the program, this is the result. And as you can see, the results that I mentioned in my presentation are represented here. And the mass of the black hole, obviously because it's being constantly calculated, it fluctuates. And it fluctuates between 1 times 10 to the 34th power and the upper, like about 9.8 times 10 to the 33rd power. If I can find an example of that. There is 9.95, but anyway, that concludes my presentation. I hope you all have a great day. Bye.